Hello class, welcome to lesson 3.5, which is all about arithmetic sequences as linear functions. By the end of this lesson, you should be able to recognize arithmetic sequences, and you should be able to relate arithmetic sequences to linear functions. So let's quickly review a few items that might be things that you've seen before. A sequence is a set of numbers, okay? We'll talk about the terms of a sequence, okay? The arithmetic sequence is when the difference between successive, so that means in order, when the difference between successive terms is constant, and the common difference is the difference between those terms. So let's look at our first example. Determine whether each sequence is an arithmetic sequence, and then explain. So if we look at our first one, we start at a negative 26, and then we go to a negative 22. So I want to think to myself, how did I go from negative 26 to negative 22? Well, I added 4. And then if I go from negative 22 to negative 18, how did I get there? I added 4 more. And negative 18 to negative 14? Again, I added 4. I just said on the last slide that an arithmetic sequence is a sequence that has a constant change in terms, a common difference. Are all of these numbers the same that I just determined to be the distance between each? Yes, so we can say, yes, this is an arithmetic sequence, and then I would say they have a common difference. To save time, I'm not going to write that all out right now. But let's look at letter B. To go from 1 to 4, I have to add 3. From 4 to 9, I have to add 5. From 9 to 16, I add 7. 16 to 25, I add 9. Okay, so I'm going up by 3, 5, 7, 9. I'm seeing a pattern here. These are all going up by 2, so is this arithmetic? If my common difference is changing by 2 each time? No. It's only arithmetic if the numbers down here are the same. So we'd say no, there is no common difference. And that would be our answer. So go ahead and see if you can determine whether 2, 4, 8, 10, 12, and so on, is an arithmetic sequence. Hopefully you determine that this is not an arithmetic sequence because the difference between the terms is not constant. If you're unsure about that, be sure to ask. Let's look at example 2. We want to find the next 3 terms of the arithmetic sequence. So we're told that these are arithmetic sequences. That means they are changing by the same amount each time. So to go from negative 8 to negative 11, I'm subtracting 3. Negative 11 to negative 14, I'm subtracting 3. Negative 14 to negative 17. Again, I'm subtracting 3. So let's figure out, if I subtract 3 more, I'm at negative 20. If I subtract 3 more, I'm at negative 23. If I subtract 3 more, I'm at negative 26. So those 3 numbers would be the next 3 terms in the arithmetic sequence. Let's look at letter B. To go from 9.5 to 11, I have to add 1.5. From 11 to 12.5, again, I'm adding 1.5. And 12.5 to 14, adding 1.5. So if I add 1.5 more, I'm at 15.5. If I add 1.5 more, I'm at 17. If I add 1.5 more, I get my third term to be 18.5. So those would be my 3 next terms in this arithmetic sequence. Go ahead and find the next 3 terms of this arithmetic sequence. Hopefully you ended up with 78, 83, and 88. If not, maybe go back and reread the problem, watch the previous example, ask a friend, talk to me. So many options, be sure to utilize one of them. Okay, let's look at example 3. We want to write an equation for the nth term of the arithmetic sequence. Okay, something really important is this box that I have up top here. I put it up here so that way we could reference it while we are working through this example. But if we want to write an equation for the nth term of the sequence, we're given that equation right up here. And I'm going to rewrite it just in case it's too small for you guys to read. But it's pronounced a sub n equals a to the first plus n minus 1 times d. Okay? A represents that this is an arithmetic sequence. N tells us which number in the sequence we're talking about, whether it's the first term, the 15th term, the 100th term. You can plug whatever number you want in for that. A sub 1 represents our first term in the sequence. It's the first number we're given. N represents the same thing on the right-hand side of the equation as the left. It tells us what term number we are talking about. And D represents the common difference. So if we want to write an equation for the nth term of the sequence, let's try that. We have a sub n equals, our first term is 3 plus n minus 1. And then what is our d? We need to find how are our numbers changing. To go from 3 to a negative 10, I need to subtract 13. To go from negative 10 to negative 23, I subtract 13. To go from negative 23 to negative 36, I subtract 13. So I'm going to multiply by a negative 13. I'm going to put parentheses around that so I don't accidentally confuse myself and think I am subtracting 13 instead of multiplying a negative 13. So I'm going to leave my a sub n equals 3. I'm going to use my distributive property. So that means I have a negative 13 times n, so that's a negative 13n. And negative 13 times a negative 1 becomes a positive 13. And then I have a sub n equals, I can combine my 3 and my positive 13. That becomes 16 minus 13n. Okay? So that would be our equation for finding the nth term of the sequence. Next, let's use that equation to find the 15th term of the sequence. So I'm trying to find the 15th term, so I'm going to replace n with 15 equals, then I have 16 minus 13, and instead of writing n, I'm going to write 15 again. So if I do 16 minus, then that would be minus 13 times 15, I end up with negative 179 as my answer. So that is the 15th term of the sequence. So you can see if you find this equation, it saves you the time of having to write out all of those. Because if we didn't have that, we would have just had to keep going. We would have said this is our first, second, third, fourth, and I would have had to find every term in between the first and the 15th in order to state what it is. Okay, so then if I ask you to graph the first 5 terms of the sequence, the way that looks is something like this. We start with an n column. We're going to make a table. And I'm going to talk about the first term, second term, third term. I'm not going to have enough room to do all 5 here. So I'm just going to show you the first 3. And I know you guys can continue from there. I'm going to put my equation here. And then I use a sub n, so whatever the value of that term is, and then I write an ordered pair over here, and then I plot those points. Okay, so I plug 1 in for n, and then if I plug 1 in, I get negative 13 times 1, which is negative 13 plus 16 gives me 3. So I'm going to plot a point at my n value was 1, my a sub n value was 3. So I go onto a graph and I plot at a dot at 1, 3. I do the same thing with the 2. I plug a 2 in. So now I have negative 26 plus 16, that's a negative 10. That was my second term, and it gave me a negative 10. So I plot a point at 2, negative 10. Negative 13, I plug in negative 13 times 3 plus 16. And if I do that, I end up with a negative 23. And then I have 3, negative 23. And so I would go through and I would plot all of these points plus the fourth and fifth terms. I'm just going to skip that to save time for you guys. And we're going to look at letter D and determine which term of the sequence is negative 114. So we want to know, if we were to write out all of the terms, what term number is negative 114? So the way that you solve this, we take that negative 114 and you set it equal to your equation. So now I say negative 13n plus 16. And I know I flipped this around from the equation that we wrote. I prefer to have the variable first. That's the only reason that I have it flipped around. So I have negative 114 equals 16 equals negative 13n plus 16. So if I subtract 16 from both sides, I have negative 130 equals negative 13n. And if I keep solving, I can divide both sides by a negative 13. And I have negative 10 equals n. Or not negative 10, sorry. I should have divided by a negative. Divided by negative is positive. So that should be a positive n. You can't have negative term numbers, so that's what really caught my attention there. Okay, so we have 10 equals n. Why don't you guys go ahead and try writing an equation for the nth term of this sequence? Hopefully you determined a sub n equals 5n minus 3. If not, be sure to ask for some help. Try this next one on your own. Hopefully for the 12th term of this sequence you ended up with 57. If not, be sure to check your work or ask for some help. Determine which graph shows the first 5 terms. Hopefully you determined that graph B shows the first 5 terms. And then which term of the sequence is 97? The 20th term. Okay, so let's look at our very last example for this problem, or for this section. Example 4, the arithmetic sequence 12, 23, 34, 45 represents the total number in ounces that a bag weighs after each additional newspaper is added. Write a function to represent this sequence. So again, we start with our generic sequence. A sub n equals a sub 1 plus n minus 1 d. So then we have a sub n equals, our first term is 12 plus n minus 1. And how much are we changing by? We added 11, added 11, added 11. So I'm going to multiply by 11. Then I'm going to simplify this. So I have 12 plus 11 n minus 11. So my final equation is going to be a sub n equals 11n plus 1. Then part B asks us to graph the equation and determine the domain. So I already have the equation graphed just to save some time. The same process that we talked about in the last example. It only asked us to graph the ones that it had already given us. So our first term was 12, our second term was 23, our third term was 34, our fourth term was 45. Notice that when you're graphing arithmetic sequences, you just have dots. You don't connect them. We only have those dots. Then we want to determine the domain. So remember, our domain is our x-axis, or our x variables. So we can say our domain, if we had 0, be 0. So we can 0, 1, 2, 3, 4, and our sequence would continue. So we represent that with dots. Go ahead and solve this last one on your own, see how you do. Hopefully you said a sub n equals 18n plus 4, but if not, be sure to ask for some help. I hope you guys have a great night.